Hey, thanks for stopping by. My name's Thomas, and this is Zarbo Audio Projects. I just finished up a pretty cool compact subwoofer project, and I thought this would be a great opportunity to run through some of the steps and thought processes of creating a subwoofer from beginning to end. So that's what I'll be doing in this next video series. I'll split the series into 3 tutorial videos: designing the enclosure, constructing and veneering the enclosure, and finally applying a finish. In this first video, designing the enclosure, we'll talk a bit about the thought process that goes into coming up with a good subwoofer design. We'll discuss some of the compromises that will need to be made, as well as some of the things to look out for as the design process proceeds. Well, we have a lot to cover, so let's get started. Before I design this subwoofer, I should back up a bit and tell you my reason for creating it in the first place. See, I have a friend at work that I wanted to build a table radio for, but I didn't want it to be too big and take up a lot of space, so I started thinking along the lines of a smaller table radio that would have nice clear sound, but not a lot of bass necessarily. Then I could create a small subwoofer that you could hide away to cover the bass frequencies. Before I designed the subwoofer though, I really needed to know what would be expected of it. So I started trying to narrow down the choices for the full range drivers that I would use in the radio. For example, if you're using very small stereo speakers, then you don't need a large subwoofer. And conversely, if you plan to use larger full range speakers for your radio, then a small subwoofer just won't be able to keep up. You sort of have to match the two. So in thinking of what speakers I could use for this radio, I remembered I'd been hearing some good things from the folks on the Parts Express Tech Talk forum about the Peerless TC9. It's a 3.5-inch full-range driver, and it does 2 things really well. It has really good smooth mid-range response, and it has a nice clean high end, to the point that using a tweeter really isn't necessary, especially for a table radio. It doesn't do bass particularly well though. It's just not designed for that. But since I'm creating a subwoofer to handle the bass duties, the lack of bass response is just fine. In the seal enclosure, it has an F3 of around 120 Hz, which makes it a pretty good choice to use with a sub. Well, now that I've decided on my main speakers and have an idea of how low they can play, I can start trying to figure out what I need for a subwoofer driver. Since size needs to be kept to a minimum, and I would like this sub to be able to sort of be tucked away in different places, I thought a tall but narrow enclosure might be the best chance of squeezing into a lot of places in a typical bedroom, for example. It could be hidden behind a couch or placed next to a dresser and not take up much space at all. And there are a few decent small subwoofer drivers that would probably work well in this setup. The Tangband W51138 driver comes to mind, but the one I ended up choosing is one that I've actually already used before. The Peerless SLS P830-945 5 1/4 inch subwoofer driver. It works well in a small enclosure and digs down into the 40 Hz range at a satisfying enough volume. It's just under $40 American, and it won't sag excessively in a down-firing configuration like I plan to use. And it looks like it might work pretty well. So let's do some modeling and find out how I came up with this enclosure size. The program that I use to design speaker enclosures with subwoofers, stuff like that, is a program called WinISD. It is a free program. It's really good, and it's not too hard to pick up. So what I'll do here is I'll go to New Project. I've already got this Peerless SLSP blah blah blah, whatever it is, it's small print. I've already used this before and it's already been entered, so I'll click Next. We got one driver we're going to use. We're going to be in a vented enclosure. We'll click Finish for that, and here it automatically populates the this dialog box with the driver information, all the specs, and it gives us a baseline kind of enclosure size right here. And it shows you the, not a bad looking curve here, honestly. It's trying to give you a starting point. I wouldn't necessarily call it optimum, but it is a starting point. And if we go over here to the box tab, excuse me, we can see that it's given us a 4.26 liter box. 4.26 liters. I have a hard time visualizing liters, so I often use another program that I have called Bassbox Pro. This is also a speaker box design software. It's sold by Parts Express. The same company, Harris Tech, has also Crossover Pro, I think. But this base box, if you look at this, let me see here, that was 4.26 liters. So if you type in 4.26 liters in base box, it gives you roughly a 6.4 by 6.4 by 6.4 inch cube. Something like that. Well, that's hardly much bigger than the speaker driver itself. And what it doesn't do is give you a reasonable vent size. So if we click on the vent tab, we can see that we've got a 4-inch vent by 72 inches long. That's ridiculous, okay? So this is just a starting point. Like I said, it gets you going. But let's click on the box tab and let's do something a little more reasonable. Say 8 liters. Okay, well, let's click on the vent tab there. That gives us a 4-inch by 37-inch long vent. That's still utterly ridiculous. But just for fun, let's type in a 2.5-inch inner diameter vent, and that gets us to a more reasonable 13.6 inches long. Okay, so this is our box size of 8 liters. Now, I'm going to be going back and forth between BaseBox Pro and WinISD just because I have a hard time visualizing the size of a cabinet. And BaseBox Pro, what it does is it draws the cabinet for you. So I already forgot how many liters. What was that? 8 liters. Okay, so let me punch in 8 liters here. So it gives you, you could say 6 by 4, 6 by 4 by about 12. That's 8 liters there. That just gives you the shape. It doesn't tell you the size of it, but you can imagine a foot long by about half a foot by half a foot roughly. And these are inner dimensions. So okay, that's not that big of a box. That's something that could be workable. I'm looking again for something as small as possible as far as my speaker enclosure, because this is it's for a young lady who, you know, has kids and doesn't necessarily want to have this big enclosure in her living area or whatever. And I find that most women are very sensible with not wanting to have a big speaker. I mean, guys, we like these big subwoofers, or at least I did and used to. Now I kind of like something smaller as long as it still works. And with today's technology, we can get smaller enclosures with the better drivers that we have. So now one of the things we need to look at too is not just the frequency response. For this frequency response doesn't look bad. These are 1 decibel gradients here. So we've got a little bit of a peak here of just a decibel. That's fine. And F3 here of about 48, 49 hertz. Well, that seems okay to me. That seems reasonable. But we got to remember that what we haven't done is we haven't looked at this other tab here on the driver tab, the driver dialog box, and this tab is called Signal. And we can see here that we're at 1 watt. Okay, so we go over here to the graph, and we go down to cone excursion. Well, we see we've got like 1 or 2 millimeters of cone excursion all the way down to 20 hertz. Well, that doesn't seem right. That's because we're only feeding at 1 watt. This is basically a baseline for the frequency response, and it doesn't really take into account how hard you're going to push the driver. So now some guys, when they're designing a subwoofer, they will say, let me look at the maximum amount of wattage that the driver can handle. In this case, power handling RMS 50 watts. So let's type in 50. Type in 50 watts here. And, oh, okay, well, we've got a little bit of a breach of Xmax here down the 70 hertz range, but anywhere from 49 hertz and down in frequency, we are very quickly starting to breach Xmax, which is this red line, which is 5 millimeters for this driver. We're starting to breach Xmax pretty bad. So there's a couple ways of looking at that. For me, if I was designing a subwoofer for home theater, big subwoofer that's going to move a lot of air that I want to rattle the walls for, you know, special effects, explosions, you know, action scenes, or T-Rex stomping through the valley, then you're going to want to take into account all that low frequency stuff and the maximum amount of power that you might want to deliver to it to get the maximum amount out of it. This is going to be a small subwoofer designed for music. I suppose you could plug in a movie and use it for that, but it's probably never going to be used for that. So I'm going to use a more realistic wattage figure of 30 watts. These are the things you got to think about and little trade-offs you make. If I design this thing to survive a full 50 watts of power, then it's going to change a lot of things about this box and enclosure and design that aren't necessarily in the best interest of what I'm trying to produce as an end result. And that'll become more apparent as we get further along here. But let's give it 30 watts, and then we look at the excursion here. Well, this excursion in the 60, 70, 80 hertz range is well under X max, and only at 47 hertz or so and down does it start to breach. And it breaches it by quite a bit, but there's very little 20, 30 hertz material in most music. I personally consider a speaker full range if I can get anywhere from 35 to 40 hertz on the low end. I think that's fine. Anything lower than that, if you're into music or listening sessions that have material lower than, say, 40 hertz, then you know you're going to need a subwoofer, and probably a fairly decent sized one to cover that. But that's not what this is about. This is a table radio, and this is a small sub for a table radio, so we don't have to worry about that too much. That, and I've actually shown you a little teaser clip earlier in this video, but this driver, even though it lists an X max of 5 millimeters, its mechanical abilities for excursion far exceed that, and by quite a bit. You don't want to necessarily count on that every time, but I happen to know that thing I pushed that pretty hard, and it didn't complain at all. I must have been like 7 or 8 millimeters easy one way, and it didn't really seem to mind. But anyway, let's go back up here to port velocity. So we got to do rear port air velocity. So at the peak air velocity, we're at 46 feet per second. It sort of depends how many feet per second of, so you have a vent, it's a tube or a slot or whatever, and air's moving in and out. The faster that air moves in and out, the more chance for turbulence that you get. It sort of sounds like this. Like a cat purring fast, really loud. And it's not a nice sound. Now, if you were designing a speaker, a bookshelf speaker with a front port, and turbulence got too high, you would probably hear that along with the music as it gets louder. With a subwoofer, it's going to be on the floor, tucked away someplace. You're much less likely to hear that. And by the time that subwoofer is making that much turbulence, your main music is going to be so loud you're probably not going to hear it. But we do need to consider it because it can get out of hand and become audible. But for this, that looks okay. So let's go over to the box size again. Now 8 liters. This is 8 liters. This is just sort of where we adjusted it to. Now let's go back to my Basebox Pro so I can visualize what 8 liters looks like. Oh, that says 8 already. All right, so we've got a 6.5 by a foot. Okay, no, that's not bad. That's not an unreasonable size of a box, but it doesn't take into account the vent here, which again is 2.5 inches, 2.5 inches by 14 inches long. Okay, well that's not awful, but maybe we can tweak it some. So let's go over here and look at the transfer function again. And WinISD has this really cool feature, which it's just amazing. But you take over here on this tab here where the driver is, you take your pointer and go over the speaker looking icon, press it down, and then move it to the left and to the right. And then you can see right there on the graph, you're actually creating a new response curve on the fly as you go. Now, if you move the graph like towards the right, you're getting into a smaller smaller box size, and if you move the tab to the left, you're basically getting into a larger box size, and you can kind of get a little bit ridiculous with it if you want to. Doesn't mean it's a good design, but it'll let you kind of tweak it to your heart's content, and it's a neat way to see on the fly what little changes do. Now, just for instance, if I wanted to get an extended bass shelf response here, so we got, with this setup, we got a, let's see, we got an F3 of about 39 hertz. Well, that sounds good. A small subwoofer that's 5.25 inches getting down to 45 or 40 hertz. 40 hertz is pretty low. But if we do that, we have to also look at what is the cone doing. I'm sorry, that's passive radio. We have to look at what is the cone. The same thing again. There you go. Tiny little letters on a tiny little screen. It's not the great combination make. But as you can see, our excursion's a little bit high, and also the the air velocity, well, that's not actually too bad. We could do that, but that is with a 10-liter box. Okay, so let me go back to base box and punch in 10 liters. That's not awful. That's not an awful size box. We got about 6.5 by 6.5 by 15 inches. That's getting pretty close to what I'm hoping for. But let me go back here and let's say, okay, yeah, well, we got a 2.5-inch vent that's 22 inches long. So 2.5 inches and 22 inches long. So that's starting to become a pretty decent sized vent for one thing. For another thing, 2.5 inches as a vent diameter isn't really doable. I think there might be pre-made vents that you can buy from Parts Express and other places. I sometimes do that for like a fancy schmancy thing, but usually I just use black ABS from the big box store from Home Depot. I'm able to epoxy that in, and you can use your router, and you can basically get the same performance as you can with a costly vent. And I have not recently been able to find source 2.5-inch vent material. I'm not saying it doesn't exist, and I thought I have used it before, but I don't see it anywhere now. So I'm going to put in 2.0 inches for the vent diameter, and that gets us down to 13, 14 inches roughly. But look what happened here at the vent velocity. It's off the scale, but let me try to find about the peak of it. We've got about 70 or so feet per second as a peak. I don't know if I mentioned it before. I meant to. I was getting there, and my train of thought got derailed a little bit. But I think between 50 and 60 feet per second is probably close to kind of like the max of what you want to be at. So that seems to me a little bit high. So let's get over here to the box tab here, and you can go up and down and tweak this for a long time. But just to shorten things up a little bit, I know you don't want to be here all day. Let me punch in the liter size enclosure that I ended up going with after much back and forth. And that is a 6.7 liter enclosure with a vent that is 2 inches by 14 inches long. So the vent is 2 inches inner diameter, 14 inches long. And in the case of the actual box that I used, the vent comes out here and it ends up going like this and then down. Well, I could have just showed you a picture because I'm going to be editing this later, but oh well. The vent has one bend in it. So in that case, so we got we have 6.7 liters. So let me hop over to base box and give you 6.7 liters. And that makes the inside of the box 13 by 6 by 6. And then our vent is a 2-inch vent by, 2 inches by 14. Now that's in red just to tell me that, well, your vent's longer than the actual box. But this is about what a 6.7 liter box looks like. And the only reason I'm showing you this base box too, in addition to WinISD, is because what does a 6.7 liter box look like? It's kind of really hard to visualize that. So I use this BaseBox Pro, this box tab, in conjunction with WinISD to get an immediate idea of what a certain liter size equates to. Now there's different programs you can use that you can visualize different sizes with. I think SketchUp will let you do that. There's also some online calculators that will give you an approximate size typed out, not necessarily visualized. But this just helps me really quickly visualize how big or small a speaker box is going to be. So that's what the enclosure ends up being. It ends up being 6 by 6 by 13 inner dimension with a 2-inch diameter by 14-inch long vent. And that is the inner dimension. I'm using 1/2-inch materials, so it's 7 by 14 is what it ends up being, the box itself. Well, let's go over here to the vent tab, 2 by 14, okay. And then we see our vent velocity is fine. We're at about 60. You don't really want to go too much higher than that. And I have heard some chuffing on this design at the extremes. But for normal music, I think it's okay. I think we're in the safe zone. And let's look at cone excursion for this. And you can see we're under the 5mm X-Max figure until we get to about 40 hertz. And then we do have pretty high excursion beyond that. this is not uncommon. You also have to consider the type of amplifier that you're going to be using with this. I'm going to be using a 2.1 channel amp that runs on as much as 24 volts DC, and a lot of these, they kind of fade the bass off on the low end. I don't know that they do it on purpose. I think it's just the components that they use end up reducing the bass on the low end, and so that's usually not as big of a deal as it might seem here. Of course, if you feed 20 hertz signals into it at 35 watts, you're going to get 13 millimeters out of it if it's not filtered in any other way, and you're going to, bye-bye driver. But usually we have some common sense when we're fiddling around with this stuff, and we don't go berserk with it. So that seems like it's okay. Now, if you're playing real low frequency stuff, like I said, and you jack it up, and your cone starts going wubba wubba, and you start hearing funny sounds, and you keep going with the volume and blow it, well, that's kind of your fault. We have to use our head with this. But for this is going to be a music system, and I do want to design a little bit of a safeguard into it, because this is for someone else. This is a gift, so you never know what someone else is going to do to the creation that you give them. They might turn, a child might get involved in it and turn the volume up way too loud, and it starts to distort. Maybe the next song's way louder. You know how some are loud, some are soft, or maybe the next song has a ton of low bass to it. So you want to design a little bit of safeguards into it. So for a trade-off between a larger box and deeper bass and a smaller box and less bass, I decided to go with a box size of 6.7 liters, a vent size of 2 by 14 inches, and that gives me here this frequency response here, which is pretty nice. It starts to go down here, and F3 is about 47 hertz. And I think that's totally fine. To me, that's a good trade-off between the lower bass that you want and being able to have some power handling and safety, and the box size. You can make the box bigger and go lower, but there's a trade-off, and I think for a gift, it's always wise to try to keep things as compact as possible, because some people just don't want this big hulking thing, in their house. So I hope you found this little quick tutorial interesting, informative, educational. I don't pretend or profess to be a WinISD expert, and you can see I myself, in order to visualize what I'm going to be building, I kind of have to use two programs, because I can't visualize what 6.7 liters is for anything. So I use the Basebox program to actually get a visual representation of it, what it looks like. But you can use another program to do that, or you might have a better idea of what a certain liter volume size is going to equate to in a finished speaker. But I just wanted to give you an idea of the process that I go through in my head when I'm designing an enclosure, and how more or less I arrived at this particular box size. Now again, I am no expert on WinISD, but I know somebody who is. Toid Audio. He's got 3 or 4 really good videos on WinISD. Somehow he's able to explain things clearly and a lot quicker than I can. But watch those if your interest has been piqued a little bit for WinISD. That'll give you pretty much all you need to know about using it and getting started with it. Well, thanks a lot for watching and sticking with me till the end of this video. I know it was a little long, but I wanted to give you the entire thought process from start to finish on how I designed this particular subwoofer. I appreciate you hanging in with me, and stay tuned for part 2, building the enclosure, and part 3, finishing the enclosure of this 3-part series with this small subwoofer project. Thanks a lot, and we'll see you next time. Bye-bye.
What?